Hello everyone. Today we're going to take a look at Docker. We'll examine Docker from the perspective of an application and go over its components. But first, let's talk about what it actually is. But before we get into all of that, in a commented format, cheat sheets help consultations. All the code from this video can be found on my Telegram channel, so go to the description. My Telegram channel will be the very first link. Head over there and subscribe. There's a lot of interesting stuff there, you won't regret it. So Docker is a tool that allows us to containerize our application. What's the point here? Let's say you have your own server. Your server is made up of many different components. For example, you might have Nginx handling your web traffic, perhaps some kind of backend service written in a language like Python or Node.js, maybe a message queue such as RabbitMQ or Redis, or even another backend system entirely. Basically, you can include anything you want depending on your needs. Now, here's the situation you might face whenever you want to make changes to your server setup, or if you decide to switch from your current hosting provider to a different one. A wide range of things can happen. There are many variables and unexpected issues that could arise during this process. You have to take this whole chain, move it to another server, and reconfigure everything from scratch. Why bother with all of that if you have the option to use Docker, which takes this whole setup, packages it into, roughly speaking, a single bundle, and you just take this bundle and launch it with a single command. What's the point here? You have the ability to define images for your, let's say, this serve. You specify the images, you specify how you'll download them, which repository to use, how you'll configure everything. After that, you launch it, and in Docker it all runs. I mentioned two interesting words. Let's take a closer look at them. We actually have three main components. There's the Imagen. Image is our container. Then we have the repository as well. What is a repository? We have Docker Hub, let's say Turnip. We have Docker Hub, which is kind of like a GitLab or GitHub, whichever you prefer. We have an image. An image, what is it? An image is where we define our configuration regarding how we will download our application, how we will configure it, which commands we will run, where and what we will copy, and so on. A container, on the other hand, is a running image. We take our image, run it, and it becomes a container. It runs, we can access it if there's some operating system inside, we can do something there, work with it, do whatever we want. We have a repository. We can also upload our container to the repository. So the current situation is clear. Now we need to understand how to work with our containers, how to work with our images, how to build them, and so on and so forth. Let's go over here. As I mentioned, to start our application, we need to write a Docker file. Here we already have a ready-made application. This is what it looks like. For Python, we have a Docker file where we specify where we'll be downloading things from. In other words, from indicates where we'll be downloading from. Let's even take a look at the Docker file. Here we have the command specified. From, where we'll be downloading from which image. Ubuntu means that we'll download the 20.04 image, after which we copy certain parts. Copy allows us to copy from our current working directory into our container, after which we make hell. It's similar to copy, but it also allows you to add files from a URL and automatically unpack archives. If we have an archive, we can add it. After that, run executes commands inside the container during the image build process. So we can run something, do an update, install, and so on. CMD is where in the end we launch our application. Entry point specifies the executable file or command that will be run when the container starts. In the same way, we simply write Python 3 apply and launch our application. Expose is actually sometimes useless because it basically just documents which port we are going to open. A container, roughly speaking, as correctly stated, here we have a container. It works here is the container. But before you continue watching, I highly recommend you check the description, go to my Telegram channel and subscribe because the newest, most up-to-date and first-hand information is released there. There, I conduct polls on which technology we'll review next. There will also be contests for free consultations and so on. There will be lots of new perks, so go to my Telegram channel and subscribe. Here is our container, it's inside. All our configurations are there, inside it. Accordingly, if a client comes along and wants to reach out to us, let's say they want to access the container, he doesn't know where we'll knock. That's why we need to expose a port from the container. You can expose a port from the container. Let's say this port will be, for example, 3000. We push our 3000 port from the container, and inside we set up some kind of mapping. That is, inside the container, it could be 3001, but externally we expose port 3000. So the client connects to our port 3000 and receives some kind of response. All right, let's take these arrows. So it just goes to our port 3000. Naturally, a different situation arises. Here we are, our client comes to our container and we have port 3000. A request is made, we do something inside. Sometimes we need to load some information, maybe upload some data or work with a database. When we work with the database is also located in a container. So the following situation occurs. At some point, we might want to stop our container, delete it, or do something else, anything at all. And every time we delete or stop something, we simply lose our data inside the container. Because we stop the containers, then later restore them. That's it. And the data disappears and reappears in the same way. That's why we have something called a volume. Volumes are a storage space where we can put our data. In other words, we simply attach it to our container. If we stop the container and then bring it back, all our data is still there and hasn't been lost. The volume is attached to the container and it's already working. There we can store our database data, our images, and so on and so forth. We can also, what was I talking about? Expose is used simply to document that our port will be open. Workdir specifies which directory is our working directory. env is used to indicate that we are working with an environment variable and setting it here. Volume creates a mount point for saving data from the container. So as I mentioned, we simply mount a folder. With Docker Compose, this will look a little bit better. And now I'll explain what Docker Compose is. User specifies the user or ID under which the run or cmd commands will be executed. Well, there are different users and accordingly different access rights. So by specifying a particular user, we also specify certain access rights for them. Arc defines variables that can be passed to Docker when building the image. We can pass some variable and work with it, but that's about it. This is not something that's used very often. It's the same with Label. It adds metadata to the image. Again, it's not really used much here. Arg is duplicated here twice. Then with copy, we also copy but with a flag, which copies files or directories from the host file system to the image file system, creating the necessary groups. There are different flags, so to speak. You can check this in the documentation. Health check is needed to periodically check if everything is okay with our container. And then stop signal sets the signal that will be sent to the container to stop it. If we set a specific signal, then in our application, we can hook into it and, for example, perform some kind of database exit or close a file that's being read. This can also be an important thing in some cases. OnBuild adds instructions that will be executed when a descendant image is built. So if we are creating a descendant image, we need to specify something. In fact, this is something that isn't used very often. Now we'll look at the ready-made application and see what's going on with it. Shell allows you to change the shell used when executing a command inside the Docker file. It's the same shell, you can basically use anything there. Okay, this is what our command looks like, the one we'll be using most often. So what do we have in our project? A Docker file. Here we have our working directory if we're talking about Python. Before working with our container, with our Python application, we need to freeze our dependencies, which we'll put into requirements. txt so that we can install them in our container. What do we see here? Here we have quite a long-standing setup. Here we're downloading some version of Python 3.8. The from statement means that we'll download the 3.8 image. After that, we create our folder with mkdir up. Then we copy using copy we copy our requirements, txt into our directory. After which we talk about the fact that it works for us. Accordingly, we'll be running everything from here. After that, we run pip install requirements txt. We run our command, downloaded everything, and already copied everything we have our app, meaning all our files. As you can see, we're not running anything here. So where are we going to run it? We'll be running all of this in the Docker Compose file. So what is a Docker Compose file? There's a lot of background here. You can actually take a look here to see what's what. We're saying that we have a Docker Compose file in this case. We can see that we've specified only one Docker file, but we have a backend, a frontend, and engines. Each of them has its own Docker file. So it's not very convenient to work this way. In what way exactly? Let's look at the workflow using just Docker, when we use commands like docker run and docker build. So what do we have here? In order to get started, well, in order to build our image, to create our image, we use docker build. We can build it as follows. Building an image from Docker files in the current directory. I've prepared some cheat sheets here, so to speak. With Docker build, we specify the name of the image and indicate where we'll be taking it from the path to our directory, which is accordingly the path to our Docker file. A single dot means that we'll, for example, take this Docker file here and give it a certain name. After that, we have the image name, then the path to the directory, and then the image is built using the specified Docker file. We can specify exactly which Docker file we want to use in particular cases. It could be a dev Docker file, a prod Docker file, and the directory from which we'll be running all of this. Then we build the image while passing build arguments. We can pass certain arguments, specifying how we want to build something so that we can reference them during the process. Next, building the image using cache. Once we've built it, we have a cache, and we can put it there so that next time we don't have to build it again. Again, this isn't something that's used very often usually. It's just a simple Docker build, maybe with a T flag or some additional options, but that's generally how it goes. Building an image without caching. If we want to avoid caching and create everything from scratch each time, we have the option to specify the no cache flag. The same thing, assembling an image with the assembly network specified. We have the ability to specify networks. There is a common global network where, for example, our containers operate. They need to be able to connect to each other somehow. They need to exchange metadata. Accordingly, we need a shared network. A shared network is set up around them, and they make requests to this shared network and receive responses. And we can specify the name of this network. How is it created? We specify it in the Docker Compose file and then build the image using multi-stage output. In other words, we simply define how the output will be generated. Then we build the image with a specified version tag. Why is this necessary? Now we'll look at this in the context of pushing to our Docker Hub. Docker Hub, as I mentioned, is similar to GitHub or GitLab, where we store our images in some kind of centralized repository. Then we build the image specifying the platform. What platform do we have? It could be AMD or it could be Intel. For all of this, we need to specify our platform. Okay. We've built our image. Here we wrote something like hello or something else. We build the image, everything is great, the build is done. After that, how do we run all of this? We have a Docker start file where we've specified a simple container launch, just run the image name, then launching the container in detached mode. We specify the name of the image we built to run in detached mode, then we set the container name. We can assign a specific name so that we can retrieve it using Docker PS and Docker images. This is easier because the commands we need to get our current containers are Docker PS and Docker images. In the current context, with PS, we get our running containers, and with image, we get our images, which we will also look at. Port forwarding, as I mentioned, we need to connect our container to the outside world. As I said, here we have port 3000, we can specify port 3000, and inside the container, it could be, say, 3000 and on our image name. After that, we can already work with it directly. Next, forwarding all ports. If we have, say, port 3001 here, and we want to expose all the ports available in our image to the outside world, we can use a capital P to specify that port 3000 will be accessible. Setting environment variables, these are our NVest and mounting volumes, meaning mounting our folders. Well, not just folders, but in general, mounting our directory. That is, we can also mount some other directory. For example, we have some build directory in our project and we will mount it to our container. And every time the container, for example, disappears, let's say it disappears and then comes back, it will still create our link to our build directory, which is located in our own directory. This is used in cases where, for example, we have some front end that we are building. In the front-end application, we have a build folder that we simply mount, we perform the mounting. Something like that. Then we have this. So. Here are the directories, the path to the directory. This is exactly where we mount the volumes, set resource limits so that everything runs efficiently overall. Naturally, we can't just, roughly speaking, give everything away, so we need to specify the number of CPUs, the memory size, the image name, and so on. Then there's running with automatic container removal after exiting it. If we want to delete something, for example, we run docker run, specify the image name, and after that, every time we exit, our container will be automatically deleted. Then a certain network is attached, and then we have running with a specified working directory inside the container. We also specify the working directory. Then setting labels, also labels just like I showed in the Docker file itself. Next, we have creating users and groups that we will work with, then restarting the container after it stops. The restart policy, we can set it to always restart every time. All of this is more conveniently configured in Docker Compose. You can see that there are quite a lot of different flags here, and specifying these flags every time would make the command too long. Here we have memory, which will be responsible for memory usage, launching the container with restricted privileges that we specify, and then launching the container with a connection to the local file system. Here we specify how and where we bind things, then launching the container with GPU support. If we have a powerful graphics card and want to offload some of the workload onto it, we can specify that as well. Then setting the command health check execution time. As I mentioned, you can specify this in the Docker file, but here we also set it during runtime. Then launching the container with volume naming, we can specify a name there, but actually it's a similar story to mounting. And then setting limits on CPU usage just like above. Here we specify both CPU and memory. Next, launching the container using a specific PID. For example, let's say we have PID 3010, and each time we want to kill it with some bash script within a minute. That's one way to do it. Then setting network resource usage limits is also available here. Okay, we launched ours using Docker run, then checked with Docker PS and saw it listed. What should we do next? Let's say we want to push it to a repository using Docker push. How can we do that? Here we have the option to use Docker push, the repository name, and the image tag I mentioned earlier. So we have the repository name hello, something else, and the image tag, plus maybe a specific image version. Then pushing the image by specifying the Docker Hub username, also pushing the image using the Docker Hub API version, and pushing the image with a specified authorization file. In some cases, we can specify the authorization here in a file. We can force push an image overwrite. If everything is different for us, just like in Git, we can make a fork and everything will be fine. Pushing multiple images at the same time, we just have a list and we can transfer it there. Pushing an image with a specified proxy, indicating which proxy it will go through. Pushing an image using the HTTP protocol, pushing an image with content trust disabled. Pushing an image with a specified push format. How are we going to upload the manifest or the layer there? Pushing an image with debug output. How will the output be displayed for us? We can do it well, the other way around. That's it. Here it's a more advanced format. The same goes for starting. For the most part, it's just a build or some kind of push or maybe a run with a certain number of flags. After that, if we wanted, we uploaded it all to Docker Hub, something like that. But for there to be a whole lot of things, that's unlikely. Why? Because we have a Docker Compose file. As you can see, creating a separate Docker file for each of our services and having to call it every time is a very tedious process. We have a Docker Compose file where we specify how and what we will use and where we'll get it from. We have a service. Well, to start, we specify the version, then the service. It's a bit of an old approach, but still, it works. We specify our backend, the name of the service, then the build section where we will build from and what context to use. Then the command that we will use to run it. Next, the volumes that we attach. We could do this during our push or at startup. Here we have the V option for named volumes, or we can do it with Docker Compose. And then what will we depend on? So for example, if we have a database, if there's a host inside, we will depend on the DB. Restart always is the restart policy. Every time an error occurs, we restart it, and that's it, it starts up again. Then the union network. We are on a shared network and can transfer our data. Okay. After that, our Nginx server works in the same way. Build where we get our Docker file from. Volumes where we mount from. Let's say we have a static. In the static volume, we store app static files. So the data that is in our static directory will be located in our static volume. then the ports that we expose from our container. So the current port in our container is the port exposed to the outside. We can specify it like this, but of course, in Nginx, we need to specify that we're working with port 8001, and then we can set it here as well. What will we depend on? On the backend and frontend, every time we restart, always the network. Which one? Union network. Then the same thing for the frontend and the same for the DB. Only in the case of the DB, we have an environment variable here that specifies our authorization data. This is our Django user, Django password, and Django DB. Something like that. We can see here that we list the volumes and we have networks. With networks, it's a bit different because we have different types of connections. There's bridge and so on and so forth. You can actually check this out in my Telegram channel. Just follow the very first link in the description and you'll find my Telegram channel there. All the advanced information is right there. So go ahead, check it out and subscribe. There's a lot of interesting stuff there. With Union Network, we launch it and it's already up and running. Okay. The Docker Compose file is needed to configure our application more conveniently, so we don't have to write Docker files in every single directory. Here, we specify the Docker files, reference them right here, so that they are compact and neat, and so that we do exactly what we need, while everything else is handled here. Actually, that's not quite the right way to put it. In the Docker file, we specify the configuration for how we will build, so that we don't have to run it using a long Docker run command that we would have to write out. And it's important to understand that with Docker run, we would have to launch each container separately, maybe with certain different flags for each one. So that would mean running our container several different times. But why do that? We just use Docker Compose up, Docker Compose build, and we already get our result. With the build command, we build here either with Docker Compose build or by calling up, and then either the build happens or our containers are started. It's already clear and we work with them in a nice organized way. Let's switch to the terminal and see what we have and how it works. Now let's take a look at how this will appear. We run docker ps, see our containers, and we can enter them. For example, we take some Postgres container and use docker exec, it's h. We see that we've entered the Postgres container, and if we want to leave, we just exit. After that, we wanted to get the images. We do that, and we see that we've received some images. We can already work with them, search through them. Again, we can delete them. With docker rm, we remove our container. With rmi, we remove our image. To go a bit more advanced, we have a docker compose file, and we want to run it. We also use docker compose. In the case of Docker, it's docker compose run, but first we just do docker compose build. We build everything as we wanted build. Build it actually takes a long time to build. And then we do docker compose up. So basically those are the commands we use. And that's basically it. We've covered most of what we need to know about Docker, configurations, help, commands. Everything you see right here will be available in the Telegram channel. So go to the Telegram channel and subscribe. It's the very first link in the description. That's pretty much all for now. Make sure to subscribe and leave a like. We'll stay in touch.